Hi everyone, in Algebra 3, today we're going to be going over your questions on lesson 69. We're going to start on number 11. So for this problem, it says, if the data are normally distributed with a mean of 0 and a standard deviation of 1, approximately what percentage of the data lies between -1 and 2? Hint, this is the same as the percentage between -1 and 0 plus the percentage between 0 and 2. So for number 11, what we're going to remember is we have the three percentages that we have to remember, which are 68%, 95%, and 99%. And for each of these percentages, it's going to be the mean plus or minus 1 standard deviation would be the range. Then for the second one, it would be the mean plus or minus 2 times the standard deviation for the range. And for the last one, it'd be the mean plus or minus 3 times the standard deviation for the range. So the mean that we are given is 0 and the standard deviation is 1. So for this one, if I do 0 plus or minus 1, the range would be -1 to 1. And that's one end of what we're trying to look for. So that's something that we need to be aware of. And then for the second one, it would be 0 plus or minus 2 times 1, which would be -2, 2, 2. And that's the other end of the value that we're looking for. So this is the left value and this is the right value. So now what I'm going to do is I'm going to draw just a standard normal table that would look something like this, or a standard normal curve, where the mean is at 0. And it's saying that the same percentage between -1 and 0. Well, between -1 and 1, the percentage, this percentage, is 68%. So what would be the percentage of just -1 to 0? Well, it would be half of that percentage. So that would be 34%. Then I know that the percentage from -2 to +2, so -2 to +2 was this percentage here, which is 95%. But I want to know what the percentage is between 0 and 2. So that would be this portion over here, which if you notice would be half of the 95%. So that would be 95 divided by 2, and that would be 47.5. Which means that the percentage from -1 to +2, this percentage right here, would be 47.5 plus 34, which gives us a total percentage of 81.5%. And that would be your result for number 11. Now moving on to number 12. So for number 12, we have to graph a logarithm. So what we're going to do is we're actually going to put this into exponential form instead of in logarithmic form by converting it. So my y is going to end up being my exponent, my base is my 5/3, and my n is the x. So for number 12, I would change that to n equals b to the L. And I'm going to make a chart for that. So that's going to be x and y. And for y, I'm going to plug in -1, 0, and 1. When I plug in -1 into the exponent, it's going to flip it. So that would become 3/5. When I plug in 0, the output would be 1, because anything to the 0 is 1. When I plug in 1, it's going to be 5/3. So when I graph this, so let's just make it very big. So it would be over 3/5, which would be about here, down 1, over 1 up 0, then over 5/3, which would be 1 2/3. So 1 2/3 would be about here, up 1, and this would be your function. Okay, so that's your graph. Now moving on to numbers 13 and 14. So number 13 and 14. Number 13 we need to write as a cosine function, and then 14 we're going to write as a sine function. So if you look with me on number 13. What I'm going to focus on is that top and the bottom value first. So I have to find the midpoint between the top and the bottom. So for number 13, the top value is 9 and the bottom value is 1. So 9 plus 1 divided by 2 would give us the midpoint. Then for B, it's going to be the top minus whatever you get for the midpoint. So top minus, so 9 minus. Now, what I'm going to do is I'm going to calculate the period length. So C would be 2 pi divided by the length of the period. So the length of the period I'm going to calculate from the peak at negative 3 pi over 8 to the next peak, which would be 5 pi over 8. So negative 3 pi over 8 to 5 pi over 8. So my length of the period would be 3 pi over 8 plus 5 pi over 8. And those pi's should cancel because we want just a fraction. I'm going to go back to A. So 9 plus 1 divided by 2 would be 5. Then the difference between the top and that value would be 9 minus 5, which would give me 4. Now, 3 pi plus 5 pi is actually 8 pi. So 8 pi over 8 would just be pi. So 2 pi divided by pi. Notice that the pi should cancel. And your result is going to be 2. And now we just need to know the phase shift. So I'm going to plug this in. I'm going to do y is equal to 5 plus 4 cosine 2. And then we're going to do the phase shift. So currently it's peaking at negative 3 pi over 8. I want it to peak at 0. So I need to shift this to the right 3 pi over 8. So shift the whole thing over this way to the right 3 pi over 8. So that would be x plus 3 pi over 8. And that would conclude number 13. So number 14 is similar, but this one we're going to be putting as a sine function. So you're going to follow the same steps for A, B, and C. So for A, we're going to look at the top and the bottom point. For B, we're going to do the top minus whatever we get for A. C, it's going to be 360 divided by the length of the period. Again, you're looking for a fraction. So currently, for my A, the top is 7 plus negative 13, and we're going to divide that by 2. And then it's going to be 7 minus whatever I get for A. And then for the period length, notice that it starts at negative 40. And then it circles down, circles up, and then ends at 80. So that means the distance would be from negative 40 to 80. So all I need to do is, for my period length, I would go 40 plus 80. So 40 was where it started, or negative 40 is where it started, but we're going to use the absolute value of it because we're looking for distance. So now from the beginning, I have 7 minus 13, and then dividing that by 2 would give me negative 3 is my A. My B is going to be 7 minus whatever I got for A, which would be 7 minus negative 3. That would give me 10. And then for my coefficient C, 360 would be divided by 120. So 360 divided by 120. Again, you want it to simplify to a fraction. So I'm going to do, write out my problem. It's going to be y is equal to A, negative 3 plus B, which is 10. Sine C, which 360 divided by 120 is actually equal to 3. And then my phase shift, well, currently it's sloping up through 20 degrees. So I would want to shift this whole thing to the left 20 degrees. I would need to move this over 20 degrees to the left. So that would mean that my phase shift would be theta minus 20 degrees. Sorry, that kind of got messed up, but this is my final equation. Then we're going to look at number 15. So for number 15, we are going to multiply those two together, meaning that you multiply the outside number and then you add the degrees. So this would be 6 times 2, which is 12. And then it would be CIS, and then we want to add 215 plus 205, which would be 420. We do need to expand this to give our answer in rectangular form. Remember that CIS stands for cosine of 420 plus I sine of 420. Okay, so 420, we're going to subtract 360 from that, and we get 60 degrees. So this would actually be 12 times the cosine of 60 plus I sine of 60. So 60 degrees is going to be in quadrant 1, where my adjacent is 1, opposite is root 3, hypotenuse is 2. So the cosine of that would be 1/2. And the sine of that would be root 3 over 2, I. And then all you have to do is distribute your 12. So 12 divided by 2 is 6 plus 6 root 3, I. And that concludes number 15. For number 16, we have 16a, which tells us 6 minus 2i, meaning it goes to the right 6, and then the negative 2i tells us up or down, so that would be down 2. So I would draw my triangle in quadrant 4. This goes to the right 6, down 2. We have to find the hypotenuse, and then we have to find the angle. We're going to use Pythagorean theorem to solve for the hypotenuse, so that would be h squared equals 6 squared plus 2 squared. So 36 plus 4 equals 40. And then the square root of 40, because it's square root of h squared, 40 divided by 2, so that would be 2 root 10. Now for the angle, we're going to use inverse tangent of opposite over adjacent. So that would be 2 over 6. And that's going to give us the angle. So 2 divided by 6 equals, and second tangent. And we get the angle is equal to 18.43. But because it's in quadrant 4, I want to know the distance from 0 degrees to this point in quadrant 4. So I'm going to have to subtract that from 360. And that would give me 341.57. And the way you write your answer is going to be slant, so hypotenuse 2 root 10, CIS, and then angle 341.57. Now for part B, we have to convert this from polar to rectangular form. And the way you're going to do that is by expanding. So the CIS again stands for cosine plus I sine. So for B, I would have 5 times cosine of negative 13 pi over 4 plus I sine of negative 13 pi over 4. That should probably be in a bracket instead of a parenthesis. Now 13 pi over 4, if I make my chart, my snowflake chart, would be 1, 2, 3, 4, 1, 2, 3, 4. Starting at 0, I would count starting in quadrant 4. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Puts me in quadrant 2. And the denominator is 4, so it's a 45-degree triangle. So this would be negative 1, 1 root 2. So the cosine of that triangle is going to be negative 1 over root 2, but we can't leave the square root of 2 in the denominator, so multiply top and bottom by root 2. Then for the I sine, it's going to be 1 over root 2. But again, you can't leave the square root of 2 in the denominator. And you also don't want to forget your I. And then you're lastly going to distribute the 5. So your answer is going to be negative 5 root 2 over 2 plus 5 root 2 over 2I. And that's part B of 16. So now number 17, we're looking to solve for y, which means we need to eliminate x. I am going to start by multiplying the top equation by the coefficient of the bottom equation's x. And then the bottom equation I'll multiply by the coefficient of the top x, but make it negative. Meaning that I'm going to multiply the top by p and the bottom by negative a. So for number 17, I would have a p x plus b p y equals c p, bottom equation by negative a, so negative a p x minus a q y equals negative a d. So your x's are going to cancel, and then you're going to have b p y minus a q y equals c p minus a d. Then factor out the y, and in parentheses you would get bp minus aq. Right side stays the same. And then to get y by itself, you just have to divide. So y is going to be equal to the right side, which is cp minus ad, over the parentheses, which is bp minus aq. Now moving on to number 18, we have to graph. So the first one's going to be a parabola because the x is squared. And the second one's just going to be a line. So for number 18, the axis of symmetry is going to be at positive 3, because if you set this equal to 0, it would be positive 3, and then the vertex would be at up 1. So 1, 2, 3, 4. So y equals x is actually just a positive slope through 0 with a slope of 1 over 1. And this is going to be a dotted line because there's no equal sign under it. And this one again, so it's a positive parabola centered at 3, and the vertex is at 1, so over 1, up 1. And this isn't going to be exact, but it's kind of what it's going to look like. So now when y is greater than, that means you're going to shade everything above the parabola, so inside of it. And then when y is less than, that means you're going to shade everything underneath that value. So for this one, if I shade above the parabola or inside the parabola, that would be everything in here. And then for the second one, if I shade everything underneath the dotted slope, that means your answer is going to be this section right here. So inside the parabola and underneath the dotted line. Now for number 19, this is going to be one of those 5 steps problems. So we're going to need a lot more space than this. So for number 19, the first thing that I would do is you're going to set the equation equal to y. So it's y equals mx plus b. You can just move the y to the other side. So for number 19, you have the equation y equals x plus 3. And then the point, you have negative 3 comma 8. So step number 1 is to find the perpendicular line of this line that goes through that point. So my slope would end up being negative x plus b. You're going to plug in that point, so that would be 8 equals -3 plus b. Because that's a positive thing, when you move it to the other side, it's going to become b is equal to 5. So my equation would be y is equal to -x plus 5. Now for step 2, you're going to set the original y and the second y equal to each other. So I'm going to set x plus 3 equal to -x plus 5. So if I move the x to the other side, I get 2x. Move the 3 to the other side, I get 2. So that means my x is going to be equal to 1. Then for step 3, you want to solve for y. So you're going to plug this 1 into either the original line or the perpendicular line. So that would be 1 plus 3. So y is equal to 4. So now I have 2 points. I have the -3, 8, and then I have the 1, 4. And what we're going to do finally is to find the distance between those 2 points using the distance formula. So I'm going to do, let's do x1 minus x2. So that would be -3 minus 1 squared plus 8 minus 4 squared. That would turn into -4 squared plus 4 squared, which would actually just turn into 32 because 16 plus 16 is 32. And 16 or 32 divided by 16 is 2. So this would actually just be equal to 4 square root 2. So 4-step problem for distance between a point and a line. Number 20 says to find the area in square centimeters of the segment segment bounded by an arc of measure 110 degrees in the chord which joins the endpoints of the arc in a circle whose radius is 0.6 meters. So the first thing I'm going to do is convert the 0.6 meters to centimeters because our answer needs to be in centimeters. So for number 20, I would do 0.6 meters, convert it to centimeters by doing 100 centimeters in 1 meter. So that means we have a radius of 60 centimeters. Now the equation for the area of the segment is as follows. X degrees over 360 times pi times radius squared minus r times r sine of x divided by 2. So my x is going to be the 110. My radius is 60. Sine of 110 over 2. So now it's just really using your calculator. And I'm going to do it to like 4 decimal places probably. So 110 times pi times 60 squared equals, and divide that by 360. And again, I'm going to do it to about 4 decimal places. So 3455.7519 minus, that would be 60 times 110 sine equals, then divide that by 2. And that would be 1691.4467. And I'm going to subtract that from the 3455.7519. And that gives me a result of 1,764.31 centimeters squared. So this one, the biggest thing would be to make sure that you convert it from meters to centimeters first so that you don't have to do it in the end. I think it does help so that you don't have to like remember the decimal places and all of that. So for number 21, the first thing that you're going to do is we're going to set each of these equal to 0 because they're already factored. So I'm going to set the tangent x minus root 3 equal to 0, and then the tangent x plus root 3 equal to 0. So if I solve for tangent x on the left, I get tangent x equals positive root 3, and you can always put your numerator over 1. Then the second one will be tangent x is equal to negative root 3, and then you can put that over 1 as well. So the first one, I'm looking for where tangent is positive. So all students take calculus. Again, everything is positive in quadrant 1. Tangent is positive in quadrant 3 because of that t. So opposite is root 3, adjacent is 1. Opposite, negative root 3, adjacent, negative 1. This is obviously going to be a 60-degree angle. I'm going to do the other one too while I'm at it. So this one, because it's positive in 1 and 3, it's going to be negative in 2 and 4. And negative root 3 over 1, then root 3 over negative 1. So just like on the last one, the angle is still going to be 60 degrees. So really what I need to do is I need to put this into radians for 60 degrees. So when I draw my snowflake for 60 degrees, remember that there's 3 arrows in between 0 and 180, and from 0 to 180 to 360, so altogether 6. But that means the denominator of every single answer is going to be 3. So my answer is going to be x equals something pi over 3, something pi over 3. So for this first one, when I count, the first one would be 1 pi over 3. So I'll just do pi over 3. The triangle in quadrant 2, I would count 0, 1, 2. So that would be 2 pi over 3. For my triangle in quadrant 3, I count again 0, 1, 2, 3, 4. So that would be 4 pi over 3. And the final one would be 0, 1, 2, 3, 4, 5. And that last answer would be 5 pi over 3. So I went through and I used my snowflake chart and then just counted around. And that gives us our coefficient for pi for each one of those. I'm now looking at number 22. So for number 22, the tricky part about this one is that we have to notice what's common within each term. And in each term, there's actually a sine x that we could factor out. So for number 22, I'm going to factor out sine x. When I do that, I'm left with 1 in the first term, and the second term, I'm left with 2 sine x. Now that I've factored, I'm going to set each of those equal to 0. So I'm going to have sine x equal to 0. And then I'm going to have 1 plus 2 sine x equals 0. I'm going to move the 1 to the other side, so I get 2 sine x equals negative 1, then divide by 2. And now for this one's going to be using the unit circle. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And sine is equal to the y coordinate. So I'm going to underline all my y coordinates. So I know that my first answer is actually just going to be 0 because this is the first place where my y coordinate is equal to 0. The second place is at 180 degrees. And 180 degrees in radians is equivalent to pi radians. So these are your first 2 answers. My second 2 answers are going to come from finding where sine is negative. So all students take calculus. I know that everything is positive in quadrant 1 and sine is positive in quadrant 2, which means that it's going to be negative in 3 and 4. And this is opposite over hypotenuse, so that would be negative 1, 2, negative 1, 2, meaning that my adjacent is going to be the square root of 3 and then negative square root of 3, and giving me that that's going to be a 30-degree angle. So anytime we're using the 30-degree angle, the chart is going to have 12 lines altogether, or 6 lines from 0 to 180. And whenever you're counting for the 30 degree, it's always going to be the line closest to the x-axis. So when I start counting for this one, I would go 0, 1, 2, 3, 4, 5, 6, and 7. So that's the line closest to the x-axis. And that would give me that my answer is going to be 7 pi over 6. Now for the next one, it would be 7, 8, 9, 10, 11. And again, this is the line closest to the x-axis in quadrant 4. So that would be 11 pi over 6. And those would be all of your answers for number 22. So make sure you're doing this in radians and not in degrees. Okay, for this next one, we are going to move the 1/3 over to the other side. And that would give me tangent x is equal to 1/3. It's tangent squared x. And I have to take the square root of both sides. And remember that when you do that, you're going to get plus or minus that value. So you're going to get tangent x is equal to plus or minus 1 over the square root of 3. So when I split it, it's going to be tangent x equals positive 1/3. And then tangent x is equal to negative 1/3. So tangent, I have to find where it's positive. So all students take calculus. We know everything's positive in quadrant 1, all, and tangent is positive in quadrant 3. It says opposite 1 adjacent root 3, opposite negative 1 adjacent negative root 3. Since it's positive in 1 and 3, that means it's negative in 2 and 4. Opposite negative 1 adjacent root 3, opposite 1 negative root 3 adjacent. And those are all going to be 30-degree angles. So I'm going to draw my snowflake chart again, just like the last one. It'll be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And we're always counting to the line closest to the x-axis. So for the quadrant 1, starting at 0, this would be 1. So my first answer is going to be pi over 6. My second answer, counting to quadrant 2, 1, 2, 3, 4, 5. So that would be 5 pi over 6. Then 5, 6, 7 would be in quadrant 3, so 7 pi over 6. Last quadrant, 7, 8, 9, 10, and 11 pi over 6. And that would be all your answers in radians, not in degrees. Now looking at number 24, so the first thing that I'm going to do is I'm going to evaluate the cosine of 210 degrees. So I have arc cosine of the cosine of 210 degrees. So 210 degrees is in quadrant 3. So negative root 3, negative 1, 2. So the cosine of this triangle would be adjacent over hypotenuse. So this would turn into arc cosine of negative root 3 over 2. And now using this chart, all students take calculus. All students take calculus and not using quadrant 3. I know cosine is positive in quadrant 1 and it's also positive in quadrant 4. So that means the only place that I can draw this triangle is going to be in quadrant 2. Labeling my adjacent as negative root 3, my hypotenuse as 2. You know what this angle is because it's the same one as the triangle we first originally used, which is 30 degrees. But because it's in quadrant 2, we're going to subtract that from 180. So my answer is going to be theta is equal to 150 degrees. So you had to evaluate the parentheses first before you actually evaluated the arc part of the problem. Now for this next one, negative 510 degrees, I'm going to evaluate that first. So negative 510 is greater than 360. So for number 25, your first step is actually to add 360 to that. So negative 510 plus 360 would give us negative 150. So negative 150 would be in quadrant 3 with a 30-degree angle. The adjacent would be negative root 3, opposite would be negative 1, hypotenuse would be 2. And then I'm evaluating cotangent first. So cotangent is adjacent over opposite. So adjacent over opposite would be positive root 3, and then we would have to square that. Cosecant is hypotenuse over opposite, so that would be 2 over negative 1, giving us negative 2, and we'd have to cube that. And then tangent would be opposite over adjacent, which would be positive 1 over positive root 3, because negative over negative is positive. And we'd have to square that. Root 3 squared is 3. Negative 2 cubed with a negative in front of it would be positive 8. And this would be minus 1/3. So really we have 11 minus 1/3, which you could write as 10 2/3, or 32 over 3. That one was easier because it gave you all of the same degrees. Number 26, we're going to change this from our roots into a quadratic equation, meaning you're going to plug this into the equation x minus root times x minus root is equal to 0. So every term changes from positive to negative or negative to positive. So my root 2 is going to change to negative root 2. My positive I changes to negative I. Root 2 changes to negative root 2, and I changes to positive I. And you're going to multiply this out. So x times x is going to give us x squared. X times negative root 3 would, oops, that should be root 2. So that would be negative root 2x. X times I would be ix. Negative root 2 times x would be negative root 2x. Negative root 2 times negative root 2 would be positive 2. Negative root 2 times I would be negative root 2i. Negative I times x would be negative ix. Negative I times negative root 2 would be positive root 2i. Negative I times I would be negative I squared, which is equal to negative 1. So now you're going to go through and eliminate the terms you can eliminate. So negative root 2i and root 2i would cancel. Negative ix and ix would cancel. We can combine the root 2x's, and we can combine the 2 and the positive 1. So this would become x squared minus 2 root 2x, and then 2 plus 1 would be 3. And that would be your quadratic equation right there. Now for number 27, what we need to do is we're actually going to draw a triangle on the outside of this, and we want to change this into meters, not into centimeters. So I guess we could start by changing them into meters, which means we have to divide by 100. So it moves the decimal point over 2 spots. So when I redraw this, I'm just going to redraw it with my new angles in it, or my new sides. So this would be 0.5 meters, and then 0.18 meters. This angle being 125. And you're going to make a right triangle on the outside so we can find the height. This angle would turn into 180 minus 125, which gives us 55. And just like all the other problems, you're going to use sine of 55 equals opposite, which is the height, over hypotenuse, which would be 0.5. So when I multiply that out, I'm going to get 0.5 times 55 sine equals, and that's going to give me a height of 0.41 if I rounded, but I'm not going to use that rounded number. I'm going to use the area is equal to 1/2 base 0.18 times whatever I got in my calculator for the height. And this is what I have for my calculator. So I'm going to take that and I'm going to multiply that by 0.18, and then I'm going to divide that by 2, and that would give me an area in meters of 1.14 meters squared. So I converted from centimeters to meters first before I actually solved. Now for number 28, if there's a number outside the logarithm, it's going to become the exponent. So the 2/3 is going to become the exponent of the 8. The 3 becomes the exponent of the x. So I actually have log 4 of 8 to the 2/3 minus log 4 of x to the 3rd equals log 4 of 4. Now the minus sign means we're going to divide. So this would become log 4. And I need to evaluate what 8 to the 2/3 is. So 8 to the power of 2 divided by 3. Oops, no. 8 to the power of 2 divided by 3 equals, and that's 4. So that'll be 4 over x cubed equals log 4 of 4. Now what I'm going to do is I'm going to eliminate the log 4s on both sides by raising it to the power of 4. So 4 to the log 4. That would be 4 over x cubed equals 4 over 1. Cross multiply that would give me 4x cubed equals 4. When I divide by 4, I get x cubed is equal to 1, and the cubed root of 1 is just 1. So that means x is equal to 1. Now for number 29, anti-log means basically that you're just going to be evaluating for the number when the base is 7, the exponent is 2.78, and then for B, it would be solving for the number when the base is 13 and the exponent is 2.78. So for number 29, I'm going to use my calculator. It's just 7 to the power of 2.78. And this one you're going to go to 4 decimal places. So 223.5489. And then for B, it's going to be 13 to the power of 2.78. And that would give me 1,249.5756. And that would be your result for number 29. So you're just solving for the number. They give you the base and the exponent. Then lastly, number 30. For number 30, since g of x is going to be your inside equation, you're going to set g of x equal to what's inside the parentheses. So I'm going to say for number 30, g of x is equal to log of x. So now I have f composite g of x equals ln of log of x. But I want to know what just f of x is equal to, which means that I need to replace my g of x with an x, meaning that I'm going to replace the log with an x. So that would become ln of x. So my f would just be ln of x. My g is going to be log of x. And that concludes all of your questions for lesson 69. I hope you guys all have a great day. Bye.